Thanks, Pete. All right, good morning. My name is Pete Fritchman. I do SRE and infrastructure things at a company called Observe. And there's an old proverb that says, the shoemaker's children have no shoes. In other words, people with specific skills or in-demand services spend all of their time providing these services to other people, and they don't have time to provide it to themselves. So internal services often lack the full SRE treatment. And I don't think this is a new problem by any means. But personally, I've always been in a role that's focused on production services and not the internal services. And at Observe, my current job, my team is responsible for both of them. So I've spent a lot of time thinking about internal services and the poor state that they're in and why they got there and how to fix it. So some definitions. What's an internal service? To me, it's anything that's not directly customer facing. It doesn't manage customer data in some synchronous, asynchronous flow. Some examples. Developer experience. You might have Jenkins, some other CI platform, a hosted VCS. You might have some platform as a service. You've got tools that ship code to production. There's probably a bunch of scripts developers run every day to set up test environments, generally do their job. You've got observability infrastructure. Maybe you self-host Prometheus and Grafana, or you have an ES cluster, data pipelines, whatever it might be. And then there's this bucket of one-off tools. Somebody spun up an EC2 instance that runs this cron job that generates, a CSV in Slack, or who knows, right? And these things always start off as, oh, it's temporary, right? We're going to turn this thing off in a week and it'll be fine. And they always evolve into these critical business processes. And you don't know they do until they break, and your team is on the hook to fix it, and it's suddenly the most important thing. You didn't know it existed 10 minutes ago. So what is this SRE treatment we have to give these internal services? And I'd say, generally speaking, it's this whole set of processes your organization probably already has around managing customer-facing services in production. So a sample of what that looks like. You need to identify meaningful SLIs, right? What represents customer experiences? You need to establish SLOs for those SLIs. What actually represents happy customers? And then you should actually measure those SLIs. Have some kind of alerting on, we're burning through too quickly, we're not meeting them. Collect supporting metrics and logs and traces and build dashboards. These are all things we know how to do. Inevitably, things break, nothing's 100%. Incident management procedures. You declare an incident, you measure customer impact, you inform stakeholders, you mitigate the problem, you find a fix, you write a great postmortem, you close the loop, you identify action items. Hopefully you actually solve and follow and close the action items. And your whole goal is to prevent the root cause from happening again. We're pretty good at this as an industry in production. So show of hands, who has an internal service at their company? Yeah, okay, so everybody, right? Okay, show of hands, who has an internal service without SLOs and great monitoring? No. Shockingly, it's the same hands. Okay. Production, what does production look like at most places? It's pretty nice usually, right? You got graphs, you have measured SLIs and SLOs. You go to bed at night feeling good, SLOs are green, customers are happy, management's happy, we're confident things are great. When it breaks, I get paged, I have tools to solve it, hopefully. We file follow-up actions for engineers, they close them. We don't see repeat root causes. Life's great, we should get big bonuses. Developer experience. The main branch build is broken again because CI didn't pick something up. Jenkins is broken and people can't even see why their builds are failing. They can't merge code because they can't get a +1 in Garrett's. The scripts developers use break all the time. You can't debug it because it's a shell script. Not only do these problems exist, but we only know about them because users tell us. I don't know about your companies, but if we write a postmortem that says the user told us and we didn't get automatically alerted, massive red flag. It's one of the largest follow-up items to fix that. It doesn't happen for DevX, for internal services often. And furthermore, like these issues and incidents are so constant, people are just used to it, right? Someone logs in and Jenkins doesn't load. They don't even go say, hey guys, Jenkins is broken. They're like, oh, it's Tuesday morning, Jenkins is broken. We go get coffee, come back, hope for the best. So people don't even report issues. So you might get this feeling of, hey, maybe things aren't as bad, but people are just used to it. They're complacent, right? Is this bad? I mean, if everyone raised their hand and doesn't have internal SLOs, maybe it's fine, right? So I've talked about these customer-facing services and internal services and how they're these different things. But what I've kind of concluded over the past year, and based on other conversations, I think a lot of people know this, Internal services do impact customers when they fail. Now, the impact isn't as directly linked as these pods are crash looping and we're serving 500s, but you can often still quantify the impact, and it's a real impact on your customers. So some examples, right? If your developer experience, SDLC infrastructure is broken, you're not shipping code. If you work at a startup and you're not shipping code, that's a problem. You could lose potential customers because you can't ship features in time. You could lose existing customers because a product manager promised them by Friday and Jenkins can't ship it. Hopefully you use automation to deploy things to production and deploy config changes in a Terraform pipeline. When that breaks, now you can't deploy changes. What happens when this breaks during an incident? Do you leave customers in a degraded state and go fix Jenkins? Probably not. You fire up the AWS console, you click stuff, you run kubectl edit at 2 a.m. and you're like, oh yeah, we'll definitely at 8 a.m. check this stuff in and fix it. That doesn't happen. You have a whole other set of problems. How do you know your internal observability infrastructure works? It's not very efficient to write a Prometheus rule to alert you when the uptime series of Prometheus is 0. It's not going to be running. What happens when the EC2 host that runs this cron job has some package upgrade and Python version mismatch and the CSV doesn't get out? You don't know about it until somebody tells you and it's on fire. And non-technically, the risk and the impact here is that you're losing trust between your SRE teams and the rest of the org. It's not very trust building to just have services that are broken and people just assume maybe you're not doing your job or you're not good at your job. And I think a big part of a successful SRE or really any kind of operationally focused team is having a really good relationship with development, with product to build SLOs, really the whole company. So what do we do about it? Easy. We just treat internal services like customer-facing ones, and we're done. It seems really obvious to say this, but it doesn't happen often. I've rarely seen it happen. SRE teams are smart, right? They usually have great people, a bunch of tools at their disposal, processes, best practices, ideas. There's a whole ecosystem around SRE. It's not hard to get information on it. But the reality is, it's not easy. Right? Technically, internal services are often a different shape than external services. You have external APIs and customer journeys that are very well-shaped and obvious, and you can find how someone else wrote an SLI for a customer journey and just kind of copy that internally. It's fine. It's just a problem there. Non-technically, right, it's often a prioritization problem. Everyone wants to fix it, but no one has time. SRE teams are lean, and it seems like they're only getting leaner as time goes on, which I think is the opposite way it should go, but And so we're told, focus on external customers. We need to build out this new infrastructure to launch this new feature to make revenue to get our Series C funding, whatever it is, right? And then you say, well, I really need to fix infrastructure. Like, builds can fail. It's like, well, Jenkins has a retry button. People can just click that, and it's probably fine. And so far, it hasn't happened during an incident, so it's probably okay. Oh, our build pipeline is broken? Well, it hasn't actually happened during an incident, so what are the chances that'll actually happen, right? Murphy's Law is a thing, and it's very real. And the reality is, like, the worst outages I've ever, worked on at any company is when a bunch of these things that never happen all happen at once. And there's no playbooks or run books. No one's ever dealt with it, and it's a disaster. And you're burning error budget. Customers aren't happy. No one's happy. It's bad for everybody, right? So I'll offer some advice later on how I've tackled the non-technical prioritization issue. But first, I want to talk about an internal service that I've spent a fair amount of time on that we gave the SRE treatment to. We have this thing called Testbox at work, and it is a collection of scripts that have been kind of organically built over time. And they set up a Kubernetes namespace to look just like production. I think everyone probably has something similar, local dev, front ends, APIs, back-end storage, all gets hooked up. Our developers use it every day. Our CI pipelines use it to run integration tests. It's pretty important. Because we have integration tests built on Testbox, now Testbox is a gate for shipping code to production. We wouldn't ship code without running integration tests. Well, half a year ago, Testbox was really on fire and pretty broken. Now, a little bit of context about Testbox. It's written in a really great language that's really easy to debug, and test and instrument. Batch. And it's not great, right? Like, yes, we should rewrite this, but we don't have the, unlimited time does not exist, unfortunately. So we live with tech debt and make incremental improvements, and, that's what we do. So the before times. We have a Slack channel just for Testbox support because it's that great. And it was busy. No shortage of problems. Doesn't work. Why doesn't this work? I get a JQ error. This is bad. And I can tell you firsthand that when you ask developers at 8 a.m. of their day to put set-x in 5 scripts, rerun it, and paste you 300 lines of output, they hate you, and they don't do it. So this whole thing escalates to engineering management as, we're not productive, we can't ship code, our test pipelines are blocked, it's terrible. And so someone on my team raised their hand and said, well, who owns Testbox code? Like, someone has to be responsible for fixing it. And our reward for asking was, we were the owners. So what do? Like, suddenly, this thing we really didn't know much about is on fire and we need like a status update. When are you fixing this? I don't know. Well, you measure it. We work for an observability company. It seemed like the obvious thing to do. So we put really basic hooks in our script that said, just tell us whether it's successful or not, exit code 0 or not, and give us a run duration. If we're drawing parallels to production, surely if you're serving HTTP traffic, you have logs and metrics about your response codes and your request duration and latency. And then you look at this, 77% for Testbox start. That's pretty bad. My boss saw this and without even blinking said, where are my 9s? Maybe if we extended it, there were 9s. But, and so when you tell people you run a 2.7 service, that's not something you put on your resume, right? You want to say 3 9s. And then the latency, 21 minutes. Like, is that bad? The people ask us that. I don't even know what we do for 20 minutes. Did it get faster? Did it get slower? What's happening? So we started by tackling the availability problem. And our first theory was, well, people are developing code. So maybe they edit some code locally and run Testbox start, and they simply have just written bad code. Like, not our problem, right? Man, some senior developers were like, no, that's not how it works. We always compile code first and then run Testbox. Solidly your problem. All right, well, I'm not going to argue with them, so we just need data, right? More data. So back to parallels, right? If this was HTTP and someone said, I have this API, it fails 22% of the time, it takes 20 seconds instead of 20 milliseconds, what's wrong? What do? If you've been to this conference for 3 days, you trace it, of course, right? So we did a thing, and I wouldn't call it elegant, it was very practical. I had an old boss who always used to tell me, Pete, perfection is the enemy of progress. What we did was not perfection. We implemented some kind of, we'll loosely call it tracing in shell scripts. I'm glad someone likes that. So fundamental concepts of tracing we're already familiar with. So we have this wonderful shell function called log event. It posts an observation over HTTP to an internal observe platform. There's an environment variable that represents your trace ID. So if you get into log event and the environment variable isn't set, hey, you're in a root span, right? And you set it to a new UUID. And so when script A calls script B, script A emits a root span, script B emits a child span. It's not fancy. It's not even good. But if we had infinite time, we'd write some awesome like eBPF, intercept exec, emit an OTel span. We didn't have time or energy to do that. We wanted to dig ourselves out. It's got a bunch of other typical bash problems if you've ever written shell scripts. If a script has its own exit trap, it overwrites this one, but whatever. This was better than what we had. We needed progress. It's close enough. So in observe, we can turn these logs from log event into spans. And someone said in a talk the other day, spans are just fancy logs. It's not even fancy, right? And so this is only a partial view because it would be like 5 slides otherwise, but you can see we spend a good chunk of time in Bazel building Docker images, and then we spend a chunk of time deploying these images to Kubernetes and waiting for them to become ready. So now we have data. When someone comes and says, hey, Testbox is slower, we can look at spans from last week and from this week and say, oh, the Bazel build is slower. Maybe there's a cache bug, or maybe there was really just a thing that recompiled the world. Maybe there's a bug in your service that doesn't report ready to Kubernetes fast enough and the deploy part is slower, but we have data now. We can actually do something or have a chance at doing something. So we let it run for a week. And I mentioned before, people use it a lot. We had a lot of data. And importantly, we logged the username with traces. So we know who's running Testbox and who's hitting failures. And so we analyzed these failed spans. And you can see up top this thing called build images fails. Maybe people really do run Testbox with bad code. Okay. But there's enough things here going on with deployments that are failing. And we don't really have a good idea of why. Now, again, if we had infinite time, we would ingest these Kubernetes logs, make some fancy dashboard that pivoted between this and that. Didn't really have time to do that. But there is a great property of internal services, and is that when they break, you can talk to these customers because they're your coworkers and they're just on Slack, right? Talk to your customers. We had data, and so we decided we're going to interview our developers. There's like 100 developers and 5 of us. But we have data. We know who uses Testbox. We know who struggles with Testbox. We know who struggles because of the non-build errors. So we can kind of focus our interviews. The nice part about internal customers, aka your coworkers, you don't really have to worry about appearances. You're not the weird vendor reaching out. You can just say, hey, I saw you ran Testbox start this morning and it failed. Did you expect that? And sometimes they're like, oh yeah, I was screwing with some YAML and terrible things happen in Kubernetes. But many people are like, oh no, cool. You guys are watching us? That's neat. So we pop up a 5-minute Zoom and kind of, hey, could you run this? Could you run that? And people really like the high touch, like, we're building our cred back of like, maybe we are competent, right? So we had, this got bad, right? We're here because everything got bad. And it turned out the problem was really dumb, as all things are, right? We had some code that tries to determine if it needs to apply Postgres schema, and there was just a logic race condition bug in there. So occasionally we didn't put, make tables in an ephemeral database, and it turns out code doesn't return ready on a Go endpoint if you don't have tables to connect to. So it was all of this resulted in like a 3-line PR to fix it, right? Now, something else we learned in these conversations, new hires are super valuable. People that have been having Testbox failures for a year are a little bitter about it all, and they expect it to fail. So when you say, did you expect this? They're like, well, yeah, it's Testbox. But new hires will tell you like, oh yeah, I just followed this new hire guide line for line and it's broken. And you get really good like candid feedback. But talk to everybody because engineers are always very opinionated, especially about things that slow them down. But our conclusion was like, this was great. We had these issues for months. Testbox was terrible. It was escalated. It was causing problems. We spent like we spent more time collecting data than we did fixing this problem was not hard. Interesting. So back to SRV Principles. We had an outage, we found a root cause, and we fixed it. What do you do next? We're SREs. We love outages. We want to get the most out of it. So we read a postmortem. And like I mentioned before, if you read on a postmortem, your customers report the error first, you should go fix that. So we hit a classic SLI issue. I think it's a classic SLI issue. Do you remember our 2.7s slide? That was actually after we fixed things. It was worse than 2.7s before. And it seems like if we use our SLI as user Testbox runs that have all these random variables of did they modify code, we thought about can we collect the dirty files in Git? This is too complicated, right? So maybe this is the wrong SLI to measure and alert against. So back to our parallel of what will we do in production, I have another SLI story for production. So you want to build an HTTP availability SLI. You're like, oh, that's easy. 200s over all requests are my 9s, right? And I want 3 9s of this. And then you ship that to production. At 2 a.m. you get paged. We're not serving 3 9s of 200s. Oh no, what's wrong? You have some customer that rolled out your Helm stack and typoed the key value in the authentication key, and they're generating hundreds of 401s every second. Okay, I don't want to get paged when customers roll out bad things at 2 a.m. So we just decide, hey, 400s mean bad request. Don't page me for that. So we update our SLI and we say, okay, well, it's really 200s over all non-400s. Cool. Ship it to production, we don't get paged anymore. Great. 2 weeks later, totally theoretical, of course, we ship a bug in our off-cache code that returns 401s to almost everybody. And we load the SLI graph and it's perfectly green and the world is entirely on fire, right? This is not good. Our bad. So we do the same thing in Testbox that we would do in a situation like this for an HTTP thing. You generate synthetic traffic. My synthetic traffic should never get a 401. If that gets a 401, something's wrong. Maybe I haven't rotated a key, but probably something is wrong. Known good parameters and alert when that degrades. Testbox is the same problem. So we write a Testbox prober that doesn't make random modifications to local Go code and Kubernetes YAML and just runs Testbox start in a tight loop. Now, it's not super simple. I mean, I feel like you could have a whole other talk on, do you build your SLIs on synthetic data or real data? How do you combine them? But next year. From our developer interviews, we know that there's actually kind of a customer journey here. So developers don't just run Testbox start. They run git pull-r, Testbox start. They apply Terraform locally. They ingest sample data. These are all of the things they expect to work. So we build a customer journey, just like you would on a web request that adds 2 items to a cart and runs checkout. So now we know when Testbox breaks, and it breaks a lot. But it's okay because we know when it breaks. And it's way easier to debug something when you can say, it stopped working 30 minutes ago, and it worked 60 minutes ago before that. You have like 10 changes to get bisect and not 1,000. It's a lot easier. It's good for our developers, good for us, it's good for our customers. Everything is great. Now we have an SLI. We got to put an SLO on it. I don't know, I think SLO, just like 9s come to mind. 3 9s sounds nice. Better than 2 7s. And you think about it, right? It's 20 minutes to run Testbox start. So if we run it back to back on some prober box, we run like 72 of them a day. If you put 3 9s against that, you're going to get paged with 1 Testbox start failure. I don't want to get paged of 1 of anything causing me to get paged. So we've had to work, and I think any SLO has the same problem. You're never going to be right first, so just do something. And if you get paged too much, move it in one direction. If you don't get paged enough, move it in another. Just iterate. Eventually, you'll find the sweet spot for it. We're taking this lesson, we're applying it to other internal services. I mentioned before how like main branch builds can fail because merge queue problems or whatever. Let's put an SLO around that. Interestingly, we're like a proxy SLO for that because when the main branch fails, Testbox start also fails because it can't compile stuff. So we got even more data than we bargained for here. But back to our SRE brain, like what's the meta root cause? Like how did we get here? Right? Like why did Testbox have to get so bad before we spent almost no time and just fixed it? It's different for every org. I've worked places where you have like a sysadmin, like very old school team running internal services. They're not building SLOs. And then you have this SRE team that's building fancy SLOs and dashboards for production. This is a great time to do cross-training. Everyone wants to learn SRE. If they don't know it, that's great. Maybe you adjust hiring, hire some SREs on the other team. Maybe you move people around temporarily, lots of options. But I think often it's just prioritization problem, like I mentioned before. So how do you convince people you should spend time on this? Before it turns into the Testbox fire drill or the 2 a.m., my CSV isn't getting emailed out. In my time in the industry, I found a couple things that I think are effective. I think for SRE, I found the most effective way to get things done in the whole organization is postmortems. You can convince people pretty easily that postmortem follow-ups are important, so write postmortems for your internal issues. File follow-up tickets. You probably have some Jira bug tracking thing where you can tag your postmortem follow-ups. If you don't, you should do this, and then you can track when teams aren't burning down their postmortem follow-ups. Because why write postmortems if you don't actually fix root causes, right? My other option is not so popular with management, but let it burn. There's a Google thing called No Heroes. There are like papers and talks about it. So you log on at 10 p.m. and you're like checking on a build, whatever, and you notice Jenkins is down. So do you stay up all night and fix it? I mean, I definitely have, and I shouldn't have. Or do you go to bed and just go, yeah, Jenkins is down. And maybe it impacts the customer. Maybe it impacts developers. Maybe it's bad. But you know what? Things change when people see things are bad. You can tell people it's going to break. But when it breaks and it's in their face and everyone complains about it, like Testbox, suddenly, instead of you going, can I fix Jenkins? Your management going, you must fix Jenkins. Like, oh, okay, you pulled my arm, right? So you fix Jenkins and you have time to do it. It feels wrong to me still to like go to bed knowing it's broken, but it's not your decision. Everyone else has decided there's no SLOs or monitoring on this. Okay. What are our takeaways? Internal services aren't internal, right? The build breaking impacts customers. It's weird to think about, but that's the mindset we need. When deployment is wedged, outages are extends. When Prometheus crashes, you don't get other SLO alerts for the rest of your service. You have observability tools already. Use them. Put more data into it, right? Data is powerful. Don't have neglected services. Maybe you don't have buy-in yet, but just do some instrumentation. Get some data in there. Data can be a powerful thing in a conversation. Oh, we know it's bad. This is how bad it is. Here's a graph that shows you it gets worse every week. That's compelling to people. Once you have this data, talk to your customers. They will like you more for it. You will learn a lot about everything. And really, the thing that is the theme is apply SRE principles. You probably already practiced them. You know them. Use the knowledge. Things are a little different internally. A cron job that runs once a month, shell scripts, Jenkins, they're not the same as HTTP APIs and external things that are easy. But when Jenkins breaks, declare an incident. Write a postmortem afterwards. File follow-up tickets. Maybe your team doesn't have a policy of doing this. Who cares? It has to start somewhere. Be the person that does it. Let it be you that files the first incident. Thank you guys for listening to my rant about internal services. Questions or just lunch? Up top.
Yeah, so internal services generally have less volume traffic than externals. And something I found, well, I think it's just happened now. As flows start breaking down, the less volume there is in services. So are there any recommendations you have in terms of the objective or level 9s for internal cooling versus external?
Yeah. I agree, and we started that with Testbox.
What number? I was going to say you're saying what number of nines, like availability nines?
Well, so the
Still a lot of breath running up here.
So the question is, you have this much lower volume of these internal services, and how do you turn that into like a ratio you care about in an SLI? Yeah, I don't know that there's a good answer. I heard the other day someone asked a question about I forget, like event-based SLI. There was some kind of I think there might be ways to do this. I don't know what they are. That was oh, perfect. Hey, it's somebody. Yeah, I would love to find a better way to do it. What I found now is that the target just looks lower. People see like, oh, you have a 90% SLO target, but context is important, right? So I think the only important thing about the number is not how good it looks. It's, is it effective when it pages you? And does it not, that's the postmortem feedback loop. Did I get paged for an SLO problem? Did customers see a problem? Great. Did I get paged and customers didn't see a problem? You got to fix it. Or did customers see a problem and you didn't get paged? You also have to fix it.
Any other questions?
Anyone else?
No, I think we're good. All right, let's give a big round of applause to Pete.